Hello, everyone. Welcome back to another beautiful episode of Just Ask Sage. Today, we are going to continue our marathon on integration by talking about the wonderful and famous integration by parts. The integration by parts formula states that integral of v du is equal to uv minus integral of u dv. Just like how we have product differentiation, we use our integration by parts when we have to find the integral of the product of two functions. Let's take an example. Let us evaluate this integral over here, x exponential x dx. Now, from the formula of integration by parts, the first thing says integral of v du. This means that our question, we have to name them according to v and du. So we'll say let v be the first function x, while du be the second function exponential x dx. Now, from our formula, aside having v and du, we have u and we have dv. Now, to get our dv means differentiate. So to get our dv, all we need to do is differentiate v. While to get our u, we already have du. So to get our u, we'll have to integrate du. Now to get dv here, we're going to differentiate our v. And differentiating x, will get 1 dx. We're putting dx here because we differentiated this x with respect to x. Now, also, to get our u, we need to integrate this du. Now, according to our integral, our definite integrals, the integral of exponential x will still give us back exponential x. It means that our u is going to be exponential x. So now that we have all our parameters, we have u, v, du, and dv, we'll put it into our formula. So if we put everything into our formula, we have integral of v, that is x, du, that is exponential x dx, is equal to uv, this u, exponential x times v, x, minus integral of u is exponential x, dv is 1 dx. So this will give us x exponential x minus integral of exponential x times 1 is exponential x dx. This makes this integral easier to solve. So this will give us x exponential x minus the integral of exponential x will still give us back exponential x. So minus exponential x. So this will be equal to exponential x into x minus 1. And this is the answer to our integral. Alright, so let's evaluate this integral over here. But before we do that, in our previous example, please remember to add your plus c. I left it on purple so that I would see if you guys would remember that after integrating any function, you add plus c. Now let's continue. We want to evaluate this integral. First of all, we need to name them v and du. Now, I'm going to be naming this log x to base e, v, because it will be easier to differentiate this. But to integrate this, there's no definite integral for ln x, but there's a definite differential for ln x. So we'll say let our v be log x to base e, which is the same thing as ln x actually. I did this because so that to get the v, you will easily differentiate ln x. But assuming I assigned it as du, assign it as du means we need to integrate it. To integrate ln x, there is no definite integral for ln x. So let's continue. So now if our v is this, then our du will be the other one, x, and don't forget your dx. Now, next is to get our dv by differentiating v, and to get u by integrating du. So our dv here, differentiating ln x will give us 1 over x, while our u integrating x remember x same thing as x to power of 1. And to integrate a function, you need to add 1 to the power, then divide by the new power. If we add 1 to this power, it will become 2. That means it will be x squared. Then divide by the new power, 2. Now that we have all our parameters, let's substitute into our formula. So we have the integral of v du, that is log x to base e du x dx is equal to u, that is x squared over 2 times v log x to base e minus integral of u x squared over 2 dv is what? 1 over x. I forgot to add the x here. Then dx. So this will give us x squared over 2 log x to base e minus integral of, here x will cancel one of the x here, leaving us with x over 2 dx. Now it's easy to integrate our x over 2. Just add 1 to the power, then divide by the new power. So this will give us x squared over 2 log x to base e minus, this is an invisible power 1. This will now be x squared, because if you add 1 to the power, it will be 2 over 2 times, you know this over 2 is the original 2 that's here, then times the new power, because we need to say divide by the new power, over the second 2 which is gotten from the new power. So this will leave us with x squared over 2 log x to base e minus x squared over 4 plus c. So this is our final answer. Alright, let's take one final example by evaluating this integral. Now in this integral, we can name any of them v and any of them du. The reason is because both of them, both x squared and cos x, can easily be differentiated, and also they can both easily be integrated. So we can name any v and any du. Let's go. So here we'll say let v be x squared and du be cos x dx. Now if we are going to differentiate v to get our dv, so our dv will be differentiating x squared, it will give us 2x, then we'll write dx because we differentiated with respect to x. Then to get u, we are going to integrate du. The integral of cos x will give us sine x. So now that we have all our parameters, we'll substitute them into our formula. So we have integral of v du, that is x squared cos x dx, is equal to uv, that's sine x times this, sine x times x squared minus integral of u dv, u sine x, then dv is 2x dx. So this will give us x squared sine x minus, we can bring out the constants 2 integral of x sine x dx. This quote. Now this question is a bit tricky because at this stage this is giving us another product, meaning that we are still going to evaluate this integral using integration by parts. So let's keep this aside for now and evaluate this integral here. So now we have integral of x sine x dx. So at this point we'll say using the same integration by parts, let v be x and our du be sine x dx. So to get our dv, differentiating x will give us 1 dx, while to get our u, integrating sine x Integral of sine is negative cos x. So putting everything in our formula, integral of x sine x dx will be equal to uv, that's this times this, that will be minus x cos x, minus integral of u dv, that's this times 1, that's minus cos x times 1 dx. So this will give us minus x cos x. Now here, minus times this minus sign will give us plus integral of cos x. Integral of cos is sine, so plus sine x. We'll not add our plus c yet because we're not done integrating the entire function. Alright, so substituting this integral we've gotten into this place here, we'll have that therefore our integral of x squared cos x dx is equal to x squared sine x minus 2 into our integral, which we've gotten here as minus x cos x plus sine x. All right, so let's simplify. This will give us x squared sine x minus times minus, this will be plus 2x cos x, then minus 2 sine x. Now sine x is common to these two, so we can bring them together and say this will now be x squared minus 2 sine x plus 2x cos x plus c, and this is our final integral. Alright, I hope with these 3 examples we've been able to understand to a great extent integration by parts. Tune in for more on our series of integration. In our next video, we'll talk about integration by partial fractions. Alright guys, have a nice day. Bye. Sage out.